Hello everyone. In today's lesson, we are going to talk about graphing a quadratic relation of the form y equals ax minus h squared plus k, where obviously a has to be different than 0. And we know why we want this to be different than 0, because if a is 0, this will disappear and it makes the equation simply linear, y equals k. So far, we have looked at the graph of a parabola, basic parabola, y equals x squared. And then we have looked at various transformations of y equals x squared. And by the way, we have finished all the possible transformations that can be applied to y equals x squared. Today, we're going to put all the transformations together and we'll apply them at all the transformations in one step. And further to this, we're going to analyze some very important features of a quadratic relation and its graph, and try to interpret all those features into real-life application questions. So let's get started. So as we have mentioned, there are two forms of a quadratic relation. One is what we call the standard form, and the standard form is y equals ax squared plus bx plus c. In standard form, we list the terms from highest to lowest degree. So degree 2, degree 1, degree 0, because x here is to the power of 0, it's constant term. The vertex form of the parabola, on the other hand, is y equals ax minus h squared plus k. And we will always prefer the vertex form, or most of the time we'll prefer the vertex form over the standard form. And that is because the vertex form of the parabola can help us graph the parabola more easily. And the reason why we call it the vertex form is because it tells us right away what the vertex of the parabola is just by looking at the equation. Now, the vertex form of quadratic function equation comes in very handy when we are graphing the function. So the way we do graph functions when they're given in vertex form is by following these two very simple steps. Step 1, So step 1, we have to locate the vertex, which is h and k. So here goes h and here goes k. And in step 2, we simply apply the pattern, which is, or it goes this way, depending on the coefficient a, it goes 1a, 3a, 5a, and we can continue on actually 7a with the rest of the odd numbers, consecutive odd numbers. Now, today we're also going to focus on some special features of the parabola, which is the vertex. The vertex will help us determine the maximum or the minimum of a parabola. Now, how do we do this? Remember that a parabola can either open up or open down. So here is a smiley and here is a frowny, right? We know that when a parabola opens up, the coefficient a is positive. When the parabola opens down, that happens when the coefficient a is negative, and that's what we try to highlight right here. Okay? When a is positive, the parabola will open up. And when a is negative, the parabola will open down. Okay? Now, what happens when a is positive? When a is positive, the vertex will be the lowest point on the parabola. And by the way, the vertex in either case is identified by the coordinates h and k, where h is the x and k is the y coordinate. Now, when the parabola opens up, the vertex will mark the lowest point on the parabola. In this case, we will say that it will represent the minimum of the parabola, in other words. Okay? Now, when a is negative, the parabola will open down, And the vertex will mark the highest point on the parabola. And in this case, we'll say the vertex will represent the maximum of the parabola here. Okay? So, what is though the actual value of the minimum or the maximum? Remember that the equation is always y equals a number. Y equals an expression, right? So, y is represented by letter k. So whether you have a minimum or a maximum, the coefficient k will be the value or will represent the actual minimum or maximum value of the parabola or the function or the relation. So we're going to say when a is positive, the coefficient k will represent the minimum value of y in the parabola or in the relation. And when a is negative, k will represent the maximum value of y in the relation. Or for short, we say the maximum, right? Or the minimum, whatever that represents. Now, how about h? Well, h represents x, right? So h will represent the value of x where the maximum or the minimum occurs. So the value of x where this minimum occurs, or the value of x where this maximum occurs. So based on what we just talked about, we are going to go over some examples. And the best way actually to kind of consolidate the understanding of a new concept is by repetition. So what I'm going to do here is, using all these equations, I will identify the vertex. Now, I'm going to get started with the first one, y equals 2x squared. You don't see the h and the k, but if you want to make it visible for yourself, you can also write this. 2x minus 0 squared plus 0. Now this will be the h, this will be the k. So we'll say the vertex is at 0, 0. Next question, y equals negative 2x squared, so negative 2, x minus 0 squared plus 0. So I'm doing the same thing. So the vertex is again 0, 0. Y equals x squared plus 2. So this will be 1, x minus 0 squared plus 2. So the vertex will be x is 0, y is 2. Next, y equals x squared minus 3. So this is 1, x minus 0 squared plus 3. So the vertex is at 0, 3. Next question, y equals x minus 4 squared. I don't see the constant here, but I see that there is something inside the brackets subtracted. So I see the h, not the k. So I'm going to add the k of 0. It won't change the equation. And now I can see that h is 4, k is 0, right? So 4, 0. Again, remember when we have a minus, the h is positive. When you have a plus, the h is negative, right? And why is that? Because the equation is x minus h squared plus k. So this minus in here, right, is this minus in here as well. So that makes h positive. Okay, so the next one, same idea. We're going to say h will be inside the brackets. In this case, negative 3, because we have a plus. And k is 0. In the next one, we have the vertex form. So h is 5, k is 1. In this case here, we have h, remember you have a plus, h is negative 3, y is 6. In this case, h is positive 1, and y is positive 2, right? Or k is positive 2. Right. Now the direction of opening. Remember what determines the direction of opening, the coefficient A being positive or negative. So when positive opens up, negative opens down. So let's take a look at each parabola. A is positive for 2x squared, so it will open up. A is negative, it will open down. Now this time A is positive, so positive 1, so opens up. Positive 1 opens up. Positive 1 again opens up. Positive 1 opens up. And we have all positives, right? The value doesn't really matter. So it seems that the rest of the parabolas will open up. Now, what is the equation of the axis of symmetry? Equation of axis of symmetry is wherever the vertex is, right? You draw a perpendicular line here to the x-axis. So this vertical line will pass through the x at the vertex. And the equation of the axis of symmetry is actually always x equals the x coordinate of the vertex, which is x equals h. So we're going to look at all the h values in here, right? And make them equal to x, and we're done. That's equation of axis of symmetry. So x equals 0, x equals 0, x equals 0. Again, x equals 0. This one is x equals 4, x equals negative 3, x equals positive 5, x equals negative 3, x equals 1. Done with the axis of symmetry. Now, we have to decide, is the function or does the relation have a min or a maximum value? And then we also have to state the value of it as well. So we're going to say, that must be related to the fact whether the parabola opens up or down. So if it opens up, it has a minimum. Down, maximum. So I'm going to make a note in here. Up, min. Down, max. Okay? So this one here, the first one opens up. So it will have a minimum. So I'm not going to worry about stating the value yet. Open down, maximum. Open up, minimum again. And it seems that they all open up for the rest of them, so we're going to say minimum, minimum, all the way down. Okay? And now we have to state the value. Remember that minimum or maximum, so or how high or how low the parabola is, it will all depend on the y coordinate at the vertex, because the y will move the parabola up or down, right? So always the min and max are represented by the coefficient k. So the coefficient k is this second number in here. So we're going to say the minimum is 0. This one here is also 0. This here is 2. This one here is 3. This one is 0 again. Another 0. At 5, 1, then minimum 1. This is a minimum of 6. And this one here is a minimum of 2. Okay. The next thing we need to talk about is the stretch. Is a parabola shorter, taller, or neither? It hasn't changed. Now, when we make these comparisons or judgments, we always compare to the basic parabola x squared, right? Y equals x squared. And we say, okay, so if we are in a parabola, I'm going to change the color a bit, just for the fun. Okay, so if the parabola is taller, we compare it to y equals x squared. Is it going to be slimmer or taller or shorter? So it will always depend on the coefficient a. All right, so if the coefficient a is bigger than 1 or less than negative 1, it will always be taller, right? Remember the little chart if you have already taken a look at it. And if it is between -1 and 1, but not equal to, it will be shorter. At 1 or -1, no changes have occurred. So the first case here, we have the coefficient A equal to 2. If coefficient A is 2, then we're going to say it's taller. The next one is -2. We're going to say, yes, that's taller as well. The y values have been stretched, have become bigger, right? So 1 means that there are no changes. So it's congruent, we say, with y equals x squared. And 1, 1, 1, 1, 1. So all these are neither. And I'm going to just write this symbol in here, which means same as above. The last one has a coefficient 0.5, which is in between -1 and 1. So we're going to say here shorter. Now there is one last definition or one last concept we need to go over: the range. Remember that for every relation we need to determine the domain and the range. And the domain, just so that we make sure here, for quadratic relations never changes. It's always any real number x, because they're defined for any real number x throughout the set of real numbers. The range, though, will be a different story. The range is determined by the y values. So would the y values have a limitation or a restriction, we should say? Now, that will depend on whether the parabola opens up or down. So if it opens up, let me choose a different color here. I think I have something in mind, purple. So when the parabola opens up, this will be the lowest value. So every y value will be bigger than or equal to the lowest value, which is marked by the coefficient k. If the parabola opens down, then the parabola will have a maximum. So every y value will be lower than or equal to the maximum value k. So again, as I mentioned, it will depend on k and a, so on the on the coefficients that affect the y value. So we're going to say that in the first case, we have a parabola that opens up. Okay, so if parabola opens up, then we're going to say that y has to be bigger than or equal to the minimum. And what's the minimum value? Well, the minimum value here is 0. Okay, so it opens up, minimum 0, so y is bigger than or equal to 0. The next one is opening down. Opening down means that y has a maximum value, so less than or equal to, and it will be less than or equal to the highest value, and the highest value here is 0, so we'll say less than or equal to 0. And you can continue on your own, but I'll quickly go over the solutions. But if you feel like it, just stop the video and try to figure this out on your own again. So y, we're going to say in this case, it opens up, right? So that means that it will have a lowest point. So every other point will be above the lowest. So we're going to say bigger than or equal to the minimum value, which is 2. So bigger than or equal to 2. Next one again opens up. So the rest of the parabolas will open up in here, all of them. So we're going to say y is bigger than or equal to y bigger than or equal to the lowest value, right? So here the lowest value is 3, so bigger than or equal to 3. Bigger than or equal to 0. Bigger than or equal to 0. Bigger than or equal to 1. Bigger than or equal to 6. Bigger than or equal to 2. Okay? So what we want to do here, oh, we have three more equations, and we actually also want to graph these three equations, which we will. And we have y equals negative